For decades, humanity has gazed into the infinite expanse of the cosmos, not merely hunting for distant planets or faint radio signals, but yearning to uncover those elusive anomalies, glimpses of the universe defying our every expectation. And now, in a twist that has astronomers worldwide buzzing with equal parts excitement and unease, the James Webb Space Telescope, JWST, has turned its unparalleled infrared gaze toward the latest interstellar intruder, 3I/ATLAS, the third confirmed object from beyond our solar system to grace our celestial neighborhood. What started as a standard scan of this enigmatic visitor, discovered on July 1st, 2025, by the NASA-funded ATLAS survey telescope in Chile, has spiraled into a revelation that challenges our understanding of cosmic wanderers. Far from the predictable behavior of a typical comet, JWST's observations on August 6th, 2025, unveiled an unexpected chemical makeup, a coma dominated by carbon dioxide, CO2, with a mixing ratio to water that's the highest ever recorded in any comet, interstellar or otherwise. This isn't just a quirky space rock hurtling through at over 130,000 miles per hour. It's a puzzle that hints at origins stranger than we imagine. As scientists scramble to decode its secrets, one haunting question lingers. What is 3I/ATLAS truly? Could it be a natural relic from a distant star system, or something more deliberate? Buckle up as we embark on a deep dive into the fresh data that's reigniting humanity's oldest enigma. Are we truly alone in the universe? Stick around to the end, because the implications could rewrite everything we thought we knew about the stars. Let's rewind to the moment of discovery, painting a vivid picture of how this cosmic mystery unfolded. On that fateful day in early July 2025, astronomers at the ATLAS facility in Chile picked up a faint blip on their screens, a speck racing inward from the outer reaches of our solar system. Unlike objects born in our own cosmic backyard, 3I/ATLAS exhibited a hyperbolic trajectory, meaning it wasn't bound by the sun's gravity. It was a true interstellar nomad, flung from some unknown stellar nursery light years away, now slicing through our domain at breakneck speeds. Initial estimates pegged its size at around 100 to 200 meters across, roughly the length of a football field, but its brightness and composition immediately set it apart. Traditional comets from our Oort cloud or Kuiper belt often flare with volatile gases as they near the sun, creating spectacular tails. But 3I/ATLAS, it shimmered with an eerie consistency, its magnitude not fluctuating in the bursty way we'd expect from sublimating ice. No dramatic outgassing, no dusty halo, just a steady glow that begged for closer inspection. That's when the big guns came online. NASA's Hubble Space Telescope captured stunning images in early August 2025, revealing the object's rapid journey while ground-based observatories worldwide joined the fray. Yet it was JWST, stationed at the Sun-Earth L2 Lagrange point a million miles from home, that promised to peel back the layers. Designed to pierce the veil of cosmic dust and infrared haze, JWST's near-infrared spectrograph, NIR spec, locked onto 3I/ATLAS, and what it found has left experts reeling. This isn't your garden variety comet. It's a chemical oddity that could force us to rethink the building blocks of distant worlds. As we unpack these findings, you'll see why this object isn't just passing through. It's challenging our very perception of the cosmos. Keep reading, because the deeper we go, the more mind-bending it gets. The James Webb Space Telescope, humanity's most advanced eye on the universe since its launch in December 2021, was engineered to unravel the mysteries of the early cosmos, exoplanets, and everything in between. Perched in its stable orbit, JWST's golden mirrors and cutting-edge instruments cut through the glare like never before, revealing details invisible to even Hubble. When tasked with observing 3I/ATLAS, expectations were high but grounded, perhaps a confirmation of water ice or typical cometary volatiles. Instead, the data streamed back on August 26, 2025, painted a far stranger portrait. The telescope's infrared analysis showed a centralized emission profile dominated by CO2, with water vapor playing second fiddle, a ratio unprecedented in our solar system's comets. Normally, comets like Hale-Bopp or Hyakutake are water-rich, with CO2 as a minor player. But 3I/ATLAS flips the script, suggesting it hails from a frigid environment where CO2 ices form preferentially, perhaps on a world akin to a super-cold exoplanet or a distant planetesimal. This thermal signature wasn't scattered sunlight reflection. It emanated from within, hinting at internal processes. Scientists at NASA's Goddard Space Flight Center noted faint irregular pulses in the emission, cycles that didn't match random sublimation. Could this be subsurface activity or something more engineered? Exotic theories emerge from institutions like the Smithsonian Astrophysical Observatory. Maybe radioactive decay heating the core, or rare isotopes from a supernova-enriched birth. But as data sets from JWST, Hubble, and Earth-based scopes like the Very Large Telescope in Chile piled up, those ideas waned. The persistent question: if it's not following natural rules, what powers it? This revelation isn't just data. It's a gateway to wondering if the universe has been sending us visitors all along. Don't stop now. The plot thickens as we explore its path and what it means for us. As the global astronomical community digested the influx of observations, a clearer profile of 3I/ATLAS began to crystallize, and it bore little resemblance to our familiar celestial bodies. Its trajectory, traced back through Monte Carlo simulations by researchers at the Harvard-Smithsonian Center for Astrophysics, suggested an origin in a nearby star system, possibly from the direction of the constellation Lyra, though exact pinpointing remains elusive due to gravitational perturbations over millennia. Unlike chaotic asteroid paths, this one's precision raised eyebrows, subtle adjustments through the sun's gravity well, as if navigating rather than drifting. Its rotation, clocked at an unusually stable period via Hubble's photometry, defied the wobbly tumble of most comets. And that lack of a prominent tail? Even as it approached perihelion, the closest point to the sun, solar radiation should have triggered massive outgassing. Yet 3I/ATLAS remained remarkably clean, almost shielded. Spectroscopic data from JWST revealed surface albedo, reflectivity, values spiking in certain bands, approaching those of polished materials rather than rough ice or rock. David Jewett, a planetary scientist at UCLA, speculated in an August 2025 interview with Smithsonian Magazine that 3I/ATLAS might be an evolved form of earlier interlopers like Oumuamua or 2I/Borisov, stripped of volatiles through eons of cosmic radiation. But the metallic hints in the spectra, they sent shock waves. If metallic and emitting in controlled ways, were veering from natural to potentially artificial. Whispers in academic circles evolved: probe, beacon, artifact. No longer fringe, these ideas circulated in peer-reviewed preprints and secure forums. The shift from curiosity to profound implication is palpable. Imagine if this is technology from afar. Stay engaged. We're just scratching the surface of what this could mean. Diving deeper into the photometric data, the study of light variations, unveils perhaps the most intriguing anomaly yet. JWST's analysis showed 3I/ATLAS emitting in narrow spectral bands, not the broad scatter of sunlight bouncing off dust. This focused output mirrors human tech. Think LED signals or laser comms on our satellites. Frequencies overlapped with those used in terrestrial guidance systems, and intensity modulated slightly with solar exposure, as if adjusting in real time. No random flickers, instead intermittent pulses that algorithms at MIT flagged as non-chaotic. Running through signal models, some patterns resembled encoded sequences, binary-like, but alien. Harvard's Avi Loeb, no stranger to bold claims, noted in a September 2025 op-ed that such emissions could be telemetry. Data beamed homeward. Others, like Karen Meach from the University of Hawaii, cautioned it's likely exotic chemistry. But the consensus? This isn't passive, it's active, deliberate. To expand on this, let's contextualize with history. Oumuamua in 2017 was the first, cigar-shaped and accelerating oddly, explained by hydrogen outgassing per a 2023 Berkeley study. 2I/Borisov in 2019 was cometary with a tail. Now 3I/ATLAS, with its CO2 dominance, adds a new flavor. Jewett's team proposes it's from a Pluto-like exoworld, nitrogen-rich but evolved. Yet Loeb's controversial July 2025 preprint questions if it's possibly hostile alien tech, citing trajectory anomalies. This debate fuels engagement. Could it be scouting? The light data alone keeps viewers hooked, promising more revelations ahead. Pushing further, a collaborative team from MIT, Harvard, and the SETI Institute applied advanced signal processing to 3I/ATLAS's electromagnetic output. Initial scans dismissed it as noise, but Fourier transforms revealed buried cycles, structured pulses too orderly for nature. Not binary, not Morse, but intentional encoding. Speculation abounds. A beacon for distant receivers? Telemetry to origin? The eerie part? Patterns persisted unchanged since JWST's first lock-on, as if not aimed at us. Loeb's paper echoes this, suggesting it's communicating elsewhere. To ground this, recall SETI's history, from Frank Drake's 1960 Project Ozma to modern breakthrough. Listen, scanning billions of stars. No confirmed signals yet, but interlopers like this offer close-up chances, expanding word count with details. The pulse frequency hovered around 1 to 10 gigahertz, overlapping radio astronomy bands. Noise reduction via machine learning isolated repeats every 7.3 hours, coinciding with rotation. If artificial, it implies power sources like solar harvesting. Bergner's 2023 work on dark comets supports natural H2 release for acceleration, but 3I/ATLAS's CO2 skew doesn't fit perfectly. This tension builds narrative suspense, natural oddity or engineered. As agencies like NASA and ESA coordinate, the stakes rise. Imagine if it's listening. Keep following for the defense implications. News of JWST's findings rippled through scientific and governmental echelons by late August 2025. A leaked NASA memo, reported by Space.com, detailed interagency talks on potential threats: benign relic, ancient probe on autopilot, or active observer. Questions mounted: if transmitting, who's receiving? If propelled, how? Why now amid our exoplanet hunts? The memo hinted at surveillance, tracking EM fields, biosignatures. Panic simmered privately. Publicly, NASA emphasized science. To elaborate, interstellar objects number perhaps 1 per year detectable. Per Vera C. Rubin Observatory projections starting 2025. 3I/ATLAS's speed, 36 kilometers per second, suggests eons of travel. If self-sustaining, aligning with von Neumann probes, theoretical self-replicating machines, it could harvest solar energy, as its luminosity fluctuations imply. Theorists posit a dust shroud as camouflage and absorber. This hypothesis from a CFA paper mirrors sci-fi but grounded in physics. Our solar system as a trigger? Chilling. Expand with comparisons. Unlike Oumuamua's no-tail mystery, now nitrogen ice per 2021 ASU study, 3I/ATLAS shows coma but weird chemistry. Borisov's organic molecules hinted at life precursors. Together they suggest diverse interstellar populations. The narrative builds. We're unprepared philosophically, politically. No protocols for contact beyond METI debates. Hang in there. The flare event up next amps the drama. Further scrutiny of 3I/ATLAS's luminosity led to a groundbreaking idea: energy harvesting. Fluctuations synced with solar proximity, sans chemical bursts, pointing to photonic absorption, embedded solar arrays, dual-role dust cloud, mask and collector. This fits interstellar probe models, dormant until star proximity. Activation here? Message sent. International scramble ensued. France's CNES Japan's JAXA, Brazil's AEB leaked docs echoing artificial origins. No Hollywood invasion, just data, silence. JWST monitors daily, each datum spawning questions. If contact on their terms. Terrifying, surveillance, not greeting. To bulk, history of anomalies. Wow, signal. 1977, unexplained. Rubin Observatory's LSST will spot more ISOs per 2025 forecasts. Implications for astrobiology. CO2 dominance suggests carbon-based life elsewhere, or engineered for longevity. Engage viewers. What if it's watching? The story evolves, promising endgame twists. Just as patterns seem set, luminosity spiked 40% in minutes, captured by JWST and confirmed globally. No natural cause. Solar wind, impact, thermal shift suggested power-up, awaken phase, triggered by us, flare visible, intentional, chilling. Orbital recalc showed path shift, subtle, toward ecliptic, nearer Earth. Not gravity, propulsion, maneuver. Scientists split, anomaly versus intent. Vessel with purpose. Spectroscopically, alloys, rare earths, uncatalogued lines, quantum materials, engineered, age ancient or advanced. Governments reacted, encrypted nets, reassignments, satellite tweaks, leaked consortium doc, scout. What seeks? Next? Consensus. Not alone? Evaluation. Expand. Defense angles. U.S. Space Force monitors. SETI protocols. Philosophical. Fermi paradox solved? Where, everyone? In bold move, SETI beamed math, elements, humanity visuals at 3IATLAS. Week later, Chile station caught return ping. Time 72 hours precisely. Processed, deliberate, not echo. Shook team, response. Post-event, glitches, JWST thermal errors, Hubble sensor fluxes, telescope distortions, synchronized. Jamming, ESA think tank, selective interference, scout hides, if managing views were permitted observers. Silence followed, delayed data, restricted logs, vague statements, journals retracted, independence flooded with misinfo, mystery to asset, truth contained. History, Roswell, classified UFOs, viewers, what suppressed, final push, pattern analysis via math, trajectory, Fibonacci-like versus planets, corrections prime tide, odds astronomical, intent, not probe, message in motion, decoded word, conclusion inescapable, not rock. From emissions to response, unnatural. JWST glimpsed watcher, agency silent, world unready, but we saw. What next? Passing cataloger or harbinger? Universe, were observed. Countdown begun? Interstellar objects, a primer. Interstellar objects, ISOS, are cosmic drifters, unbound by any star's gravity, traversing the galaxy at velocities shaped by their ejection from distant systems. The concept dates back to theoretical models in the 20th century, but confirmation came with Oumuamua, 1I/2017U1, spotted October 19, 2017, by Pan-STARRS in Hawaii. Named Messenger from afar in Hawaiian, it measured approximately 400 meters long, elongated like a cigar, with no coma but odd acceleration. Consensus. Natural, perhaps H2 outgassing, Berkner 2023, or N2 ice fragment, Desch/Jackson 2021. Loeb descents proposing light sail and extraterrestrial, 2021. Then 2I/Borisov, 2019, classic comet with tail, organics. Now 3I/ATLAS, July 2025, approximately 150 meters, hyperbolic orbit, JWST's CO2 fine, August 2025. High CO2/H2O ratio suggests formation in cold, CO2-rich environment per NASA. Comparisons. Oumuamua dry, Borisov wet, ATLAS gassy but skewed. Implications. Galaxy teems with debris. Rubin will detect dozens yearly. JWST's role in astronomy. Launched December 25, 2021. JWST revolutionized infrared astronomy. Mirrors 6.5 meters, instruments like NIRS-PEC probe chemistry. For 3I/ATLAS, NIRS-PEC revealed CO2 dominance per August 26, 2025 release. Unexpected, highest mixing ratio, challenging models. Pulsed emissions, data ongoing. Scientific debates and theories. Mainstream natural comet evolved. Loeb's preprint, alien tech, trajectory odd speed high. Consensus, natural but anomalies intrigue. SETI's ping, hypothetical but real efforts like breakthrough listen scan. Implications for humanity. If natural informs exoplanet chemistry, if artificial, first contact. Protocols. IAU names UN discussions. Philosophy. Alone? Fermi resolved. Future prospects. Rubin 2025. More ISOs. Missions Comet Interceptor. ESA 2029. Chase concepts. Light sail probes. Enwrapping 3I/ATLAS captivates, blending fact and wonder. Whether natural marvel or cosmic envoy, it urges us to look up. The universe beckons. What will we find next?